Hello viewers, myself Abdul Bari, Associate Professor in the Department of Civil Engineering of K.S.Rangasamy College of Technology, Trichandur. Here we are going to discuss on properties of surface and solids under the course Applied Mechanics. Before going into detail about the properties of surface and solids, here we are going to see about the centroid as well as the areas. The equivalent force and centroid problem has many cases. For example, if it is not a force that has been being integrated, but volume or area are to be found out. For example, suppose if we are taking a bar with a triangular cross section which is under the tension force, and similarly if the bar is of long, that is if it is of more than 4 times the width of the bar, then we can assume that the tension is uniform throughout the cross section, that is at the middle length along the member. This is known as the uniform stress distributions. So in the figure we can able to see the bar, the tensile force has been applied on the both the direction of the bar. F load has been applied as a tensile force, and because of the tensile force we can assume that the tensile load is been acting at the mid length of the bar, and that mid length we are going to call as a uniform tension stress in the bar. Now we are going to see about the center of gravity and centroid. Center of gravity. It is a point where whole weight of the body at one particular point is called the center of gravity. Whereas in centroid, the plane figures which is having only the areas but no masses. The center of the area is of such a plane figure is known as the centroid. The method to find out the centroid of the figure is same as that of finding out the center of gravity of the body. Both the centroid and center of gravity will be denoted with the letter CG or C. So the process of finding out the centroid of the figure may be of the 3 types. With the help of the 3 methods, we can able to find out the center of gravity of a simple figure. So by geometrical considerations, we can able to find out the centroid of a simple figure. By moment method also we can able to find out, and by graphical method we can able to find out the center of gravity of a figures. Consider the plane figure, that is center of gravity of a plane figure. Consider the uniform rod with the length L. The point AB has been shown for the starting as well as the end point of the particular rod, and the length of the point A and B is L. So for this rod, if you want to find out the center of gravity, the center of gravity can be taken as L by 2. That is at the midpoint of the rod AB, we can able to find out the center of gravity of this particular uniform rod. So the center of gravity of the uniform rod will be at the middle point. Consider the center of gravity of a rectangular sections. So the rectangular section means we are having the L as well as the B on the point. L into B is the size of the rectangular sections. So the center of gravity of a rectangle is at a point where the diagonals meet each other. So it is also the midpoint of the length as well as the midpoint of the breadth of the rectangle. So if L is the length of the rectangle and B is the breadth of the rectangle, the midpoint, that is L by 2, is the center of gravity along the x direction, that is along the length directions, and B by 2 along the breadth direction, that is along your y directions. So the area of the rectangle can be taken as L into B, and the centroid of the point will be taken as along the x direction it is of L by 2, and along the breadth direction it is of B by 2. So it also be said as the diagonals meet each other at a particular point. That point you are going to call as the center of gravity of a rectangular sections. Now the center of gravity of a square. It is also the point where the diagonals meet each other. Consider the square with the dimensions A on both the sides. If we are finding out the centroid along the x direction, we can able to say as A divided by 2. Similarly, if you are going to say the directions or center of gravity along the y direction, means it is also A divided by 2. So along x direction as well as the y direction, the center of gravity of the square will be of a divided by 2, and the area of the square can be taken as a into a, that is either it is of a square or it is of 2 times of the a. We can able to say a into a as the area of your square. Now here we are going to see about the center of gravity of the parallelogram. So the center of the parallelogram is nothing but a point where the diagonals meet each other. So in all the rectangles, square as well as the parallelogram, the diagonal point, that is the meeting point, intersecting point, you are going to call as the centroid of that particular body. It is also the midpoint of the length as well as the height of the parallelogram. Consider the parallelogram ABCD. Here in this parallelogram, AB is the length of the parallelogram and AD is the height of the parallelogram. So the centroid of the parallelogram can be taken as the midpoint along the length directions as well as the midpoint along the height directions of a particular parallelogram ABCD. Here now we can able to see an example problem to find out the center of gravity. So find the center of gravity of a 100 mm by 150 mm by 30 mm T sections. The T sections has been given in the figure. So you can see the dimensions. The T section means we are having the web as well as the flange portions. The flange portion dimension is 100 mm by 30 mm, whereas the web portion dimension is 150 mm by 30 mm, and the 150 mm is the overall depth of the T sections it has been taken. So the height of the T section has been taken as 150 mm and the thickness of the T section has been taken as 30 mm. For this section we want to find out the center of gravity. So with the help of the formula we can able to find out the center of gravity. So formula is nothing but, if you are finding out the along your y directions, the formula will be of a1y1 plus a2y2 plus a3y3 divided by a1 plus a2 plus a3. That is the formula. If you want to find out the center of gravity along the x direction, it is the formula like a1x1 plus a2x2 plus a3x3 divided by a1 plus a2 plus x3. Why are giving x1, x2, x3 means, or a1, a2, a3 means the more number of the bodies. A1 it is the area of the first body, A2 it is the area of the second body, A3 area of the third body. Considering the T section we are having only 2 bodies, that is web portions as well as the top flange portion. So A1 and A2 will be there. Similarly x1 and x2 will be there, y1 and y2 will be there. Since it is a T section, symmetrical sections, we can able to calculate the x bar as 100 divided by 2. Since it is of a symmetrical sections, mirror section, if you are taking the mirror of the x direction, we can able to have equal better. So it is of 100 divided by 2 is 50 mm along the x directions. While calculating the y directions, we have to take into 2 bodies. First rectangle consider as a top portions of 100 mm by 30 mm. So the area of the top portion is 100 mm by 30 mm, that is 100 into 30. So the area A1 will be finding out as 3000 mm square. Whereas for the second section we can take it as rectangle EFGH. Only the web portions we have to take it. For the web portion dimension is from the height 150 mm, we have to neglect the 30 mm flange thickness. So if you are neglecting the 30 mm flange thickness, the web portion dimensions we can arrive as 120 mm by 30 mm. So the area of the web portion can be calculated as 120 into 30 mm. It will be of 3600 mm square. So the area we have found out as A1 as 3000 mm square and A2 as 3600 mm square. So summation of the area will be 3000 plus 3600. It's nothing but 9600 mm square. Now we have to calculate y1 and y2 for this T section. Y1 for the flange portions, we can able to consider the reference line axis. Here it has been found out the reference line from the top. So the flange portions y1 we can able to get it as 30 divided by 2, it is 15 mm. Whereas for the web portion it is of 150 minus 30 divided by 2, it is of 135 mm. If you are taking from the bottom, that is if you are considering the reference line from the bottom, the y1 and y2 will be of getting like this, that is y2 will be of 120 divided by 2, whereas y1 is 130 divided by 2 plus 120 will be there. Here I am giving us from the top. So from the top means it is of 30 divided by 2 of 15 mm is y1, and 150 minus 30 divided by 2 will be getting us 135 mm for the y2 from the top portions. We can also able to calculate from the bottom portion also. As I said, it is of 120 divided by 2 is y2, and y1 is 120 plus 30 divided by 2. So 30 divided by 2 is 15, and 120 plus 15 is, it is of 135. In both the ways we can able to get the answers for y1 and y2. Now we have to multiply both the area as well as the y1. So a1 into y1, a1 is 3000 into y1 is 15, and a2 is 3600 into y2 is 135. So the summation of a1 plus a2 will be arriving as 531,000. So putting into the formula, we can able to find out the y bar as a1 plus y1 plus a2 into y2 divided by summation of a1 plus a2. We can able to get the centroid as 94.09 mm.